Hello, good morning, everybody. I will take remote control for this presentation. My name is AnnSofie. I work for ZULU Associates. We are an innovator in the maritime component of logistics. We are creating a new type of inland waterway barges and also seagoing vessels that are remotely controlled without crew on board and zero emission. And I will lead you through the Central European demonstration case today. And I'll start with giving some background on the European level. You can see here the map of the Trans-European Transport Network. And all these colored lines are logistic lines where cargo has to be transported from A to B through road, through railways, through inland waterways, through the air, like seamless, very good. And 7 of these corridors contain also inland waterways. So inland waterways is quite an important, even though maybe a bit not so much known transport modes in Europe. Next to that, there's also the NAIADES program. And in that program, some action points are noted down that are very important for actually for all transport modes, but especially now for inland waterways, which is supporting modal shifts, greening the fleets, and focusing a bit more on digitalization and supporting the current and future workforce. So there's plenty of things to do on European level for inland waterways, and I am very happy for that. If we zoom a bit more in, if the next slide wants to come, yes, there it is. Then we are more in the west of Europe, and there's actually the place where most of the inland waterway vessels in Europe are coming from and are sailing. And especially in the countries that are member of the Central Commission for Navigation on the Rhine, there most of the vessels are sailing, and that's the most, not the most, but one of the most used club of waterways. But as you can see in this part of the slides, it looks like my mouse is also moving. Yes, many of these vessels are very old. And you can see, for example, dry cargo vessels, 83% of them is made between 1900 and 1999. So that leads to quite some, I would say, a bit of worries for inland waterway sector, because old vessels are not green at all. It's often very expensive to retrofit them to make them more green. And if you look at inland waterway in specific, it's often so that it's not so much a big company that has a lot of ships. It's usually a one-man company having one vessel, and it's very, very expensive to change their ship into something more green. So this might, or will just not support the goal of NAIADES to green the fleets. Also, not only the vessels are quite old, it's also often the crew that is getting older and older, and there's not so much new people coming into the transport sector. So that might mean that we will have less and less ships on the waterway and modal shift won't be achieved. I am trying to get to the next slides. There's a lot of latency, and I hope this latency will not be the same in our ship later, because then we'll have a lot of problems. Anyway, the slide of a modal shift. The pictures you see is the ring road in Antwerp, which is very busy, and actually this picture is not even so busy as in real life. And underneath is a picture of the Albert Canal, a class 5 canal, which is sometimes not so much used. So there's a lot of possibilities for modal shift, and we really want to support this. But as I already said, there are quite some challenges for that. Even though like on European level, we want to have an increase in the usage of inland waterways. You can see in the figures here that inland waterways is the red part. That at least for the calculations of in Belgium, that by 2040, the inland waterways will stay quite small. And if you compare to 1989, it will just even decrease. And the usage of trucks will increase. And that's not at all the way to go. And there is where this demonstration case comes in, because the case will take place right in the middle of this trans-European transport network. And in this place between France, Belgium, Netherlands, and Germany, at least 3 of these corridors come together. And if we zoom in on the Western European place, it's the Rhine countries again. So there, this demonstration case will take place. It's a place that is already very much used, and it really needs the support to switch to a greener fleet. So with this demonstration case, we want to show that we can reduce the truck traffic and reduce emissions up to zero. We want to improve the logistics chain in this region through digitalization. We would like to have a 24/7 operation with reduced or no crew. And actually, as a whole, the goal of this demonstration case is to show that if you want to transport a container, because that will be the ship, it will be a container ship that we will use from start to end point, that everything, all steps in between have to go seamless. So a seamless door-to-door container transport. This is this is the route that we are planning to use. And we chose this route that starts in Dourches or Lille in France, going up to the port of Antwerp, then going from Antwerp through the Netherlands and ending in Duisburg. We chose this route because in the analyses that the people from Valencia Port made, they see that a lot of companies are actually located around Lille, around Dourches. There's a connection with Paris, there's a connection with the ports there as well. The part in Belgium and the part in Netherlands is very highly used as well. The port of Antwerp is one of the biggest ports in Europe, has connection with inland waterways, has connection with seagoing vessels. And Duisport is the biggest inland waterway port in Europe and has even a train connection all the way to the east of the world. So this is a place where a lot of logistics, transport links, they all come together. And that's why we want to have this part of Europe as the background for our demonstration case. The goal is that we can show kind of a feeder loop vessel that has just in these specific two places on the map has a loop. It's zero emission, it has no crew on board, and through different building blocks that Vasilis and also Hovard have explained already a bit, that this loop is just going very efficient and seamless. It's a very exciting project, and luckily we don't have to do it alone. ZULU is providing the ship, and I will give some more information about it later. But we have plenty of other partners who are helping out making this demonstration case reality. We have DST, who has their port research lab, and it will be used to have a live coordination of the demonstration case, and they're also taking care of the scientific analysis that is focusing on the logistics and the economical side, the nautical side, the ecological side. Port of Antwerp, Bruges, and Duisport are providing their infrastructure, and they are helping with all the tests in their parts of the roads. McGregor, Awake AI, and Valencia Port are all giving their innovations, and I will give some more information about them later. We have ISL, who provides logistic operations, risk technology, and they support a bit on the legal and regulatory side. And the same for EDIT and VNF. They're also supporting very much on regulatory issues, legal issues, and the risk technology. So great team to work with, and I'm very happy I can work with them. All right. Then I'll go through the different innovations for this demonstration case. And the first one is the X-Barge and the ROC. The vessel you see here is not built yet, but will be built in the next 12 months. It's a SEMT class 4 vessel, so it's not the biggest. That was not me. How can I go back? Now I need some help. Yes, thanks whoever it was. So the vessel, SEMT class 4 vessel for inland waterways. It will be unmanned. Probably for the demonstration case, it might happen that there are people on board because we're still negotiating with the governments on reducing the crew. But it's actually designed for unmanned traffic. We have the blue boxes there. These are containers, and in there is whatever that can be in it, as long as it's zero emission and green. But for the time being, we think that batteries are the most efficient to use. So for now, batteries in there. They can be swapped in different ports. and that's how we will make sure that our travel is zero emission. We will have an autonomous mooring crane on board, a bit more on that later. So a few of these containers, the yellow ones, will be taken out, and the mooring arm will be placed on there and takes care for mooring. If that would not be possible anywhere else, there's also the, you can see here the classical way of mooring. But let's forget about that, because in this demonstration case, we want to go for no crew on board, and that's why we want to demonstrate the mooring arm. Let's see if there's something else. There's so much more to talk about this vessel, but let me just keep it there for now. And any questions about the vessel can be asked later or can be mailed. All right. Let's see if this changes now. Yes. All right. ModelNet has already been introduced, but ModelNet will be the first part of the whole demonstration in this number 2 demonstration case. It's where a client or a person who wants to send a container, he goes to ModelNet, he says, I have this container, it needs to go to Duisport in our case. What is the best way for me and the cheapest way or the greenest way to get this container to the end destination? And that's when ModelNet is going to search through this engine, what is the easiest way to transport a container? Is it through roads, is it through train, is it through inland waterways? It will be through inland waterways, of course, and it will set up the way. And during the transport, you can check through ModelNet like real time where the cargo is located. If your container or the containers are getting to the ship, there will be the VCOP. That's McGregor's innovation. This system knows about the stability of a specific ship that has been selected through ModelNet, and it will know how to load and unload the ship and make sure that the stowage plan is okay according to stability. And when the vessel arrives at a certain port, it will also be the system that will connect with the terminal operating system and will make sure that the right containers are unloaded and that the loading again is happening through the right sequence, take into account the stability of the vessel. The third innovation is the AVSPM by Awake AI. So if a vessel enters a port in advance, this system will make sure that the vessel has a berth allocated, that it communicates with the port on the practicalities that need to be done. It will give information to the ship or to the ROC, then in our case, on where to go. Actually, it kind of takes a bit over the VTS in the port, or it like interacts with it. So you can already know in advance where to go and you don't have to wait too long. Everything should be going much more smoothly. And then the last innovation that will be shown in this demonstration case is the mooring arm of McGregor. So it's how it looks like on the picture, more or less, but it will be mounted upon a container. It can detect the bollards itself. It knows how to reach them. It also knows if it can't reach it because there's something going in between. So obstacle detection. In other words, it can be operated remotely. Probably for the demonstration, we will have a person on board to make sure that everything happens safe, but the mooring arm has been tested enough that it actually can operate on its own. So this is everything that we're going to showcase, and this is how we will do it. And I actually almost said it already before, so I'm just going to repeat myself maybe. So the vessel, if somebody wants to have the containers from Lille to Duisburg or to Antwerp, to between one of these three, thank you, is too early. Can we go back, please? So through ModelNet, I can do it without the map. Through ModelNet, the container will be allocated to a vessel. Great, thank you so much, Paula, for your help. To a vessel, the vessel will be loaded thanks to the VCOP. I guess I'm not going to take remote control now. I'll just leave it like this. And in Lille, there will be the port of Lille. There will be a specific moment where we will really test deeply, thoroughly the VCOP system, how it works with the containers on the X-barge. Then we'll sail all the way to Antwerp, and it's in Antwerp that the port call planning will be showcased. So a bit in advance, we do a pre-port call planning, and then when we enter the port of Antwerp, the AVSPM will make sure that the vessel has the right place to berth. The mooring will then be done by the mooring arm of MacGregor, and then again the VCOP comes back. That takes care for the loading and unloading with the terminal operation system. If it might happen, because you see here there are some little dots on the waterway. These are locks. If it might happen that there is, I don't know, traffic jam or so at the lock, or there's a serious delay, these delays will also be put into modal nets. So you, as the owner of the container, you will be able to see where is your container and how much delay is there. And it will also be possible to like adjust the route afterwards. But we will think everything is going fine. We're on time in Antwerp. So from Antwerp, we go to the Netherlands. The ship will go on its way until Duisburg, and it's also in Duisburg then again that the VCOP will be like more in-depth check how it works there. It's an integration with a different terminal operation system, and it will also take care for the loading and the unloading, and ModalNet again will make sure that all the information that is needed is on time with the owner of the containers. And I think that's a bit of the overview of the case. Yes, I think that's about it. If there are any questions, then
Thank you so much, AnnSofie. There's a question in the chat.
yeah, let me read. I guess you meant ship emissions don't depend on the ships, but on the propulsion systems. We see a range of older and newer engines in IWT. It is possible to have current engines running on renewable drop-in fuels to enable significant emission reduction. The renewal of the fleet is absolutely important, hence also this project which has our full support, thank you. But it will not be realistic to renew the entire fleet in the short run unless there's a very promising business case, which we would like to support with adequate regulation for the green and digital transition. Yeah, that's true. It's not possible to just switch everything at once. The idea with this specific X barge is that it won't be just one vessel, because one vessel won't change anything. It will be a fleet of green vessels. Like I said, with the containers, it doesn't really matter what's in it as long as it's green. And I think by time, also because older vessels will disappear, there will be space for newer types of vessels. But of course, things go step by step, and we won't have a change immediately. But it's important to show to the world that there's actually a solution that is not super expensive, but competitive with the regular way of working in inland waterways. Also, I saw that Karin had
Any
a
more
question
questions?
about release also in the chat. Maybe we can also look at that.
Yeah, sure, sure. The Karen, because Karen was yes, that I will bring that back when Vasilis takes over. But I see Odruna has a
Okay,
question for you as well.
all right.
Okay, thank you. Very briefly, you mentioned it's a lot of old ship and all personnel on board in this ship, and it's expensive to change them. Is there any common founding system who could give a kick on that to change the old ship with a new green ship? And also, I have a question when you are totally unmanned, and this is inland water voyage. So, who will be the ship's owner and safety responsibility of this type of ship? Thank you.
Who will be the ship owner is a question, and who will be responsible for the safety?
Yeah, that is the same in according to ISM code.
Okay. I must admit that I'm not so much familiar with ISM, and I don't think it applies to inland waterways. It applies to the ports, seagoing. Maybe I'm wrong. But what I can say is that this vessel is not going to go on the inlet waterways or seagoing, if it's a seagoing vessel, if there is no agreement with the government or no proof that this vessel is actually safe. So we at ZULU Associates are making a very thoroughly analysis of everything that the government wants to know on how the ship functions, if it would be unmanned. And we're also not going to go unmanned like this. We will start with the minimum crew that is needed, and from there start testing with remote control and checking our criteria for proving it's safe, and only then, and when the government agrees, we will reduce the amount of crew. So this can take months and a year or a bit longer. So that's why the demonstration case will probably be with crew on board still, because we're not there yet with the government. But the technology itself should actually be able to work without crew. So that's how we check the safety. Our ships can be used through a time charter. So then I would say that the safety is a bit of a mixed responsibility, because we would still be responsible for updates and maintenance and making sure the vessel is in a good state, which also means it has to be safe. But the companies that use the ship will also have their own responsibility with safety. Does that answer your question?
Yes, thank you. You know, anyway, if it's inland water, as I pointed out, if something go wrong, you need a person you can shoot on. So that's was my question.
Yeah.
And I'm very happy about your story about the mooring system and the old-fashioned way, because this MacGregor arm, if it run out of power, you need to have the old-fashioned way to mooring
Yeah.
the ship. So thank
Yeah.
you.
Yeah, we also have mooring plates where we can do the vacuum mooring or the magnetic mooring as well. So we have 3 options. It's gonna be fine.
Yeah, that's good.
Thank you so much, Vasilis.
Yeah, just to add to what AnnSofie said, a very interesting aspect of utilizing autonomy in maritime and inland waterway shipping is that um, the business model, maybe it will change, and the actual vessel owners, instead of having a dedicated maritime company, maybe the vessel owners will also be the actual cargo owners. And this is what we are seeing in the ASCO use case that Håvard presented as well. So this is also a very interesting aspect of autonomous shipping that, yeah, we will explore as well.
Thank you so much,
Yeah,
Nick.
thank you.
Nick, you have a say here. Can you maybe go on with?
I think that's a good remark that Nick writes. If there is a link between ModelNet and Euris, it's something I just wrote down to have a check with the people from ModelNet, because I think it might be interesting to see what could be, like, how they can help each other, how they can be aligned. If that is how I understood the question correctly.
Hello, AnnSofie. Been a long time.
Yes.
For those who are not familiar with Euris and Ceres, Euris and Ceres are kind of a product coming out of the RIS River Information, what is it, Services Systems, and you could consider it as the digital backbone of inland waterway transport. And RIS Comex as a project, which are the founding fathers of Euris and Ceres, are trying to extend the backbone so that it's can be part of a more integrated supply chain.
Thank you so
Did I
much.
say this correct, Karin?